Dear student, let us try to learn about SAR of 1,4-dihydropyridine derivative. So today we are going to discuss about the SAR of some chemical moiety. Before going to study the SAR, हमें पहले we must have to remember all possible structure of 1,4-dihydropyridine. Then it is going to be very easy to understand the SAR of this structure. Let us go ahead. The first and foremost thing is 1,4-dihydropyridine. So if we bifurcate this structure or this derivative of the name into two parts, we can say it is pyridine derivatives. So dihydro, so compared to pyridine, it have extra two H atom, or I can say H2 molecule, one H2 molecule. Let us go ahead. This is pyridine. If you calculate total number of hydrogen, one is at here, 2, 3, 4, 5. So normally pyridine containing 5 hydrogen. If it is 1,4-dihydro or any other dihydro derivative, it should have 2 extra hydrogen. So this derivative containing 7 hydrogen total. Pyridine containing 5 hydrogens. Dihydropyridine containing total 7 hydrogen. If we see here, then we give the number, then it is 1, 2, 3, 4, 5 and 6. If you find a hydrogen presented here, so 1 is here, 2, 3, 4, 5. These are normal hydrogen present in pyridine derivative. But if you see here, these are the extra hydrogen. This is also an extra hydrogen. So I can say that this is a 5,6 dihydropyridine derivative. Dihydropyridine derivative. The similar way if we see here, so it have hydrogen, it is written at here, that is good. Second, third, fourth, fifth, sixth. Now what are the extra hydrogen present at that position? Is one at this one and another one is this one. So compared to pyridine. If we will see here, then it is 1, 2, 3, 4, 5 and 6. So I can say this is 1,6 dihydropyridine derivative. If you see here, there is total number of 5 hydrogen, it have total number of 7 hydrogen, it have total number of 7 hydrogen. Now whatever we are thinking here, 5,6 derivative, that means 2 extra hydrogen is present, one it at the 5th positions and another one is at the 6th positions. Another we have seen that it have a extra hydrogen it at the 1 position and 6th position. So it is known as a 1,6 dihydropyridine derivative. If we see here, one extra hydrogen is this one, and if we will see here, then we come to the conclusion that the extra hydrogen which is present is at the 4th positions. So this is our interesting or our intent molecule, or this is 1,4-dihydropyridine derivative. Is it? Now we have to more focused on here. Okay. So if we see here and go ahead to understand the major part of the structure 1,4-dihydropyridine derivative. So first one is this one. So if you see here, this is 1 and this is the fourth positions. Another one is phenyl ring substitutions. So at the fourth position there is phenyl ring. And if you see among this all, so I can say or to make it in easy form, I come to the conclusion that in one position 1 minus 1, in the second position 2 minus 1, at the third position 2 minus 1. This is, so the answer is 1, this answer is 2. So I can say this answer is 0. So from 1, 2 and 3 we substitute 1 or we subtract 1, we are getting the answer, and based on that answer we come to the conclusion that this is 0. So I can say no substitution at all at the position 1. This is trick. Then it answer 1. So we can say normally at the two positions 1 carbon is there. So there is 2. So normally we can say at the third positions, normally 2 carbons are present. This are normally, some of the exceptional cases are that we will remember. So if you say this is a third position, this is third position, and if you see in the mirror, the third position look like this. So I can say that most probably at these positions the functional group is ester. And if you come at the fourth positions, there is no double bond, so we cannot subtract anything, but we can say the LOCK. So lock containing 4 alphabet. So from that I can use it and come to the conclusion that at the fourth positions we have atrope isomerism lock. So if you see, this is not exactly this structure, but to show you how is it locked. So this is a phenyl ring. If you see here, this is phenyl ring. So in the phenyl ring, if this positions, so I can say this group is this one, or it could be this one also. And this green color, this one, this is green color or this red color would be, I show you in this figure, is this one, or it is X. So where it is, this is at ortho positions and this is at meta positions. So if I want to lock between these two, then most probably position is this one, and sorry, this, the position is this one and position is this one. At here it cannot do lock positions, or it cannot do the lock. So these are the main part of a 1,4-dihydropyridine derivative. Let us see how one by one. So first we will see 1,4-dihydropyridine ring is essential requirement for the activity, because its names itself shows that it is 1,4-dihydropyridine derivatives. So in this case we are focused at here 1. In a trig, I told you that there should not be any substitutions, because 1 minus 1 is 0. So substitution at the N1 position, this is N1 positions, what happened? Decrease or abolish the activity. The second is use oxidized piperidine ring or use of reduced pyridine ring, that also give the same effect like this. This is also giving the same effect. So ultimately I told you that, so p-pyridine oxidized form, if we will do the reduction, then we are getting the oxidized form, and if we will do oxidation, then we are getting the reduced form. So oxidized form is produced by reduction, and reduced form is produced by oxidation. So this derivative, if I do reduction, that means I add hydrogen and break the double bond, then I got the oxidized form, that is piperidine. And if I do oxidation by removal of two hydrogen and introduce a double bond in a 1,4-dihydropyridine ring, then I get the pyridine. But everything will abolish the activity because it is written it here 1,4-dihydropyridine derivative itself, so we cannot change anything. So after the first position, we move to the second positions, and the second positions and sixth positions, they are the mirror image with each other. So whatever the treatment we are giving at the second position, same treatment we should have to give at the sixth position. So this is the possibility. So C2 and C6 methyl group is the best. It gives the activity except amlodipine. So amlodipine is say that I am special. I am special. It itself shows that this is amlodipine. Then let us go ahead. 1,4-DHP receptor can tolerate a larger substituent at this position. So what it indicates that if you keep here a larger substitute, then the receptor can tolerate. It is going to be blocked. Second is, after that we have a C3 and C5 positions. They are also the the similar treatment we have to give to 2 and 6 positions. And I told you that the mirror image of the 3 is like this. So we come to the conclusion that it is available in the form of acetyl group. Is it? So this is one by one we have to go 1 positions, 2 and 6 positions, 3 and 5 positions. So that story of 1,4-dihydropyridine ring is over and it is essential. Let us go ahead. We have phenyl ring substitutions. So if you see here, this is phenyl ring. Now the fourth positions I told you we required for the lock. A lock is very important. If we lock our room with a small lock and a very large lock, so it is important size of the lock. Shape of the lock is not important at all. So I can say size, how big lock is that, and where you have keep the lock, कितनी बड़ी साइज का लॉक है और आपने कहां पे लॉक किया है. That is very important. There is no effect of electronic nature. So I can say if I want to lock it, this ring between the 1,4-dihydropyridine and the phenyl ring, I require to do the substitution at ortho positions and little bit at the meta positions. Then and then this two can lock. This two can lock the similar way also at here ortho and meta positions. This and this can lock. This and like this. This two cannot give the lock or they cannot block each other at here. I showed you in ectropysomerism. So I can say that compound with ortho and meta substitutions is they can block the 1,4-dihydropyridine ring and the phenyl ring. So they are the best or for the optimal activity. Or we can say यहाँ पे कुछ भी substitution नहीं करते. Or we cannot give the para positions also. Or we give the para positions. We cannot do anything, then it just rotate it. This can easily rotate. If you will not give, this can rotate like this. And if you will give at para position, then also it can rotate. So the first case, in case of ortho and meta, it is best. It possesses optimal activity. But on substitutions or the para substitutions, it does not give the ectropysomerism lock. It does not give this lock. It gives this lock. And we require to do the lock. So the para and unsubstitution does not give this activity or less the activity. What is isomeric lock? So if we say conformational isomer, those which are form the conformational isomer, wherever we have single bond, they can easily rotate, and that due to rotation is can known as a rotation formation conformations. So where we will do the lock? Which two? If we lock, then we have two door, and we lock the door. What are the two door we are locking? One is uh, 1,4-dihydropyridine and C4 aromatic ring. They are perpendicular to each other, and they are going to be locked. That is known as a heteroisomerism lock, and that lock is essential, and lock is done by ortho and meta substitution on phenyl ring. Let us go ahead. Phenyl ring is also essential. Instead of phenyl ring, if I keep any heteroaromatic ring, if I keep the heteroaromatic ring, there is not at all issue. If I give the 6-member ring, it can do the lock because there is no electronic effect. हमने देखा है कि इलेक्ट्रॉनिक का कुछ भी इफेक्ट नहीं आने वाला. So what is an important size and positions? So position is the fourth position or the same position. If I keep here same 6-member ring, then it can lock. It give the activity. It have this activity. Produce similar therapeutic effect. But pyridine produce animal toxicity. Due to that, we are not using a pyridine instead of phenyl. So if I want to block, I required 6-member aromatic ring. Simple, with the help of small non-planar alkyl group or cycloalkyl group that cannot used at all because they cannot easily lock, because in case of alkyl we cannot block. In case of cycloalkyl we are not able to block it. To block it we required 6-member aromatic ring that can lock it. But lock is not important. After that we required also less toxicity, so decrease activity. Let us go ahead. Structure of 1,4-dihydropyridine. So here I give you some trick. So most probably the second position is over, one position is also over. Now where we have to think it here? The first is, this is an R1. The second one is, this is our R2. Third one is, this is our R3. Is it? And at the last I say that this is my X. So in case of, when you remember the structure, you have to find out the similarity, and then you have to come to the conclusion whatever the odd observation that you have to remember. So first we start with this X. So in X, whatever the substitution with this name start with the nitrogen or N alphabet, they all containing NO2. And the name which start without nitrogen, they have no the name does not start with the nitrogen. So this we can say this all are 2-chloro, 2-fluoro. We require this electron withdrawing group at here. So here also we have to find. So wherever the F, the friend of F in the periodic table is Cl. So हमारे फ्रेंड के वहां पे शादी होगी तो हम कपल में ही जाएंगे, सेकेंड एंड द थर्ड पोजीशन is set. So in case of Nifedipine, the M is here. It indicates that at the third positions, that is meta positions, right? I told you that This is a third positions. We required a minimum 3 minus 1, that is 2 carbon. So if you see here, all containing a 2 carbon. Okay. But in case of nimodipine, we are blocking at the meta positions. तो यहाँ लॉक करने की जरूरत में साइज बड़ी हो जाएगी, क्योंकि यहाँ से लॉक करना इजी होता है ऑर्थो से. But when we want to block it at the third position, we require a somewhat more size. So double of the 2 is 4. So we are using isobutyl or butynate. So this is the structure like this. 1, 2, 3, 4. Like this it is actually. So X is over, R2 is, R3 is over. Now we come to the second positions. If you say the second position, this is at this, okay. This is similar. That also containing this ester. The third position is okay. We require the fifth position. This is the similar way. And nifedipine is a first member of this group. So in case of nifedipine, they have tried to the similar way, or whatever the substitution at the R3 position that was kept in R2 positions. That is 2 carbon. But after that, we have to, our important is here size to lock it. So they have increased the size. So in case of amlodipine and phalodipine, they have just improved or increased one carbon. So nimodipine, in case of that, it is at meta positions. So we required a size and a specialized treatment. So in case of that, we have used a 3 carbon. From here to here, they have used plus 1 carbon, plus 1 carbon. So in that case of here, they have used plus 1 carbon. That is 4 carbon with oxygen. So in case of nisodipine, iso what is there? And in that case, they have used 1, 2, 3, 4, 5. Iso pentyl. This is similar like this, but 5 carbon containing iso. Is it? And it itself shows that I am a special. So in case of I am a special, this all containing the methyl group at one position are one positions, that is 2 minus 1. But amlodipine, am, this word start am means amine. So NH2 containing 2 carbon, then oxygen containing 1 carbon. What it indicate? It indicate that NH2 ethyl oxygen methyl. So I can say amino ethoxy methyl. Amino, this start with amino ethoxy methyl. If you, I have given some trick to remember it. If you try in such a way, you can easily remember. Second case, how many atom? 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. So in case of nimodipine and nisodipine, they required 5 carbons or 5 atoms at least. So this is the trick. In case of amlodipine, one position I am a special. In case of phalodipine, friend of chlorine. In case of nifedipine, I am a first member. I must have to the similar. In case of nimodipine, this meso, and we required a more size to lock it. In case of nisodipine, I required the iso group. Is it? Let us go ahead, and one slide SAR is that no substitution, small alkyl group, ester, electron withdrawing group at ortho and meta position is best. So let us go ahead, and this is the SAR of our 1,4-dihydropyridine derivative. Just to make an interest in the medicinal chemistry, I have done it. And if you like this, and if you have an interest to learn this, if you want any another video for that type of medicinal chemistry, Please write in the comment box in YouTube so I can serve the society. Thank you. Thanks a lot.